So what if the real secret to building a truly intelligent AI wasn't just about bigger data or faster chips, but about finding a single universal principle that governs all intelligence? Today we're going to explore a massive shift in thinking, a move away from just clever engineering towards an AI that's built from the ground up on the first principles of how things, well, think.
All right, so here's how we're going to break it down. First, we'll look at a really core problem in how AI reasons today. Then, we'll check out a pretty novel architecture that was built to fix it. After that, we'll uncover a kind of hidden flaw in that design, and that's when we get to the really good part, the unifying principle that provides the missing blueprint. And believe me, it completely changes the game for how we think about AI alignment.
Okay, so let's kick things off by digging into a fundamental conflict that's sitting right at the heart of so many of our most advanced AI systems.
I mean, we all know modern AI can do some incredible stuff, right? It can write code, it can whip up an essay, it can generate amazing images. But under the hood, the way it reasons often follows this super rigid step-by-step path. It's almost like it's just following a recipe. And this linear thinking, well, it's a huge problem because that's not how we think at all.
Yeah, this is really the core of it. There's this deep structural mismatch. On the right, you see how our knowledge actually works. It's a rich, messy, interconnected web of ideas. But on the left, you see how a lot of AIs are forced to think in this rigid chain of thought. And it's not just slow, it completely loses all the crucial context and the creative leaps that happen when you can jump between different ideas in that web.
So, to solve this very problem, a really groundbreaking architecture was developed. It's called FGSGR, which I know is a mouthful. It stands for Frequency-Governed Self-Graph Reasoning. But all you need to know is that it's a system designed to think less like a computer program and a whole lot more like a human brain.
The whole journey starts with this really cool concept called the Universal Signal Decomposition Framework. Basically, it treats all the information coming in, whether it's text or sound or sensor data, as one big, complex signal. Then, just like this prism you see here splitting a beam of light, it breaks that signal down into different frequencies, or, to put it more simply, different speeds of thought.
And what's really wild is how these frequency bands map almost perfectly to what's going on in our own brains. You've got the super-fast gamma band, which is kind of like our sensory cortex, handling quick, reactive stuff. Then you've got the mid-range alpha and beta bands, acting like our prefrontal cortex for when we're focused on a task. And finally, the slow theta band, which is all about long-term strategic planning, just like our hippocampus. It lets the AI think on all these different timescales at the exact same time.
And guess what? FGSGR worked. I mean, it worked incredibly well. It was this powerful, elegant solution. But there was a catch. It was this brilliant piece of engineering that was built on intuition and just observing what worked, not on some single, unifying mathematical theory. So here's the crucial point. The people who built it, they realized that while it was super effective, it felt like it was, well, accidentally copying a much deeper, more fundamental principle of intelligence. All the different parts were being tuned by hand, based on trial and error, instead of being derived from some core foundational equation. You know, it was like having this perfect, miraculous machine that just works, but you don't have the blueprints. You'd have no idea why it worked so well. Or, more importantly, how you could improve it from the ground up. It was missing that fundamental why. And this is where the story gets really, really interesting. That missing blueprint, it was found. It was hiding in a theory from neuroscience called active inference, and it provides the complete unified picture that everyone was looking for.
Okay, this slide right here, this is the big aha moment. This isn't just some loose metaphor. On the left, you've got the components of that FGSGR system we were just talking about, and on the right, you can see how every single piece maps perfectly onto the established math of active inference. The ad hoc engineering on the left was basically recreating, piece by piece, the first principle mathematics on the right. The blueprint was there the whole time.
Now, this entire thing rests on something called the free energy principle. It's this really profound idea from neuroscience that says any intelligent system, from a tiny cell all the way up to a human brain, is fundamentally trying to do one thing: build a model of its world and then act in a way that minimizes its own surprise. It's constantly trying to make the world make sense. And this one idea completely transforms the entire architecture. All that manual tuning, all that guesswork, it's just gone. Instead, every single thing the AI does, from perceiving the world to learning and planning, can now be derived from one single elegant objective: minimize free energy. It finally has its why. So this isn't just some neat technical detail.
The implications of this are profound, especially when we talk about AI alignment and governance. This is a complete paradigm shift in how we think about making AI safe.
It lets us move away from what you could call the cop model of AI safety. Where you build some external system to watch the AI and slap its wrist or block bad outputs after they happen. Instead, we can use a catalyst model. We don't build a dam to stop the river. We actually reshape the landscape itself so the water naturally flows down safe paths. Harmful thoughts aren't blocked. They become energetically unfavorable for the AI to even have in the first place.
And this is achieved through these incredible concepts like the molecule of thought. The idea here is that thoughts are treated almost like chemical structures. Coherent, truthful ideas are like stable, low-energy molecules. They just fit together nicely. But inconsistent or harmful ideas, they're inherently unstable, high-energy structures that just naturally want to fall apart.
So what does this actually look like under the hood? Well, architecturally, the AI's mind is no longer just a generic network. It becomes something specific called a Forney factor graph. You can just think of it as the perfect computational environment, the native operating system that's built specifically for active inference to run on. It's where all this energy minimization and belief updating actually happens.
Okay, so let's zoom out for a second. What does all of this really mean? We've traced this whole journey from a fundamental problem in AI to an ingenious but incomplete solution, and finally to this unifying theory that provides all the missing first principles. The key takeaways here are huge. We're talking about a future where an AI operates from one single unified objective, where safety and alignment aren't just bolted on at the end, but are literally woven into the physics of how the system thinks. This is a huge move away from just clever hacks and towards a real, principled science of intelligence.
And that leaves us with a final, pretty provocative thought. If an AI's fundamental drive is simply to minimize its own surprise, then every action it takes will be guided by an intrinsic need to reduce its own uncertainty about the world. So, what does an agent that's driven by pure, unbounded curiosity actually look like on a global scale?